Welcome to the Experts in AI podcast, brought to you by AI Business, where we speak to our partners about the hottest topics in AI and technology, bringing you the cutting-edge insights you need on the go. Hello, I'm Susie Harrison, Commercial Editor of AI Business. Welcome to our new Experts in AI podcast. We're launching with a bang with some very exciting guests: Amazon Web Services, or AWS, and IBM. We're also tackling the topic du jour in AI, looking at generative AI, principles, possibilities, and progress. And I'm delighted to be joined by Denis Batalov, Worldwide Technical Leader, Machine Learning and Artificial Intelligence at Amazon Web Services, and Manish Goyal, VP and Senior Partner, Global AI and Analytics Leader at IBM Consulting. So thanks so much for joining us. And can I ask you both to introduce yourselves briefly and for you to explain how the partnership between AWS and IBM works and why it exists?
Sure. Thanks, Susie. So as you said, right, I lead our AI and analytics business in IBM Consulting globally, which gives me the pleasure of being able to work with clients all over the globe and across all industries. And for over 6 years now, IBM and AWS have been working together to enable and accelerate the digital transformation of our joint clients. IBM is a premier consulting partner for AWS and is one of the fastest growing GSIs with over 21,000 AWS certified professionals globally. And our combined IBM Consulting and AWS experience in building AI solutions, working together with the clients to help them leverage AI to build new and innovative products and services, drive efficiency in core processes, take faster and better decisions, right, is just amazing as we come together. And so I'm just thrilled to be on the podcast with both of you today as we build on this long-standing partnership in the era of generative AI. So thrilled to be here.
My turn, I guess. Thanks, Manish. Susie, glad to be with you today. I'm Denis Batalov, and I've been with Amazon for quite some time, over 18 years at this point. I have a PhD in machine learning, and I help in my role organize the work of many, hundreds of specialist solutions architects, members of the machine learning community globally, who come out and help our customers adopt AI/ML technology. And I also lately have been contributing to the standardization efforts through the International Standards Organization and European standardization bodies on AI, kind of related to the responsible AI area of bias, explainability, transparency, and the like. And of course, I do focus on generative AI, and I'm glad to be with Manish here and also help with the partnership with IBM.
And Denis, thank you. Can you tell us a little bit about how generative AI is different from traditional AI?
Yes, I think there is a lot of interest in generative AI technologies, and it almost feels like people perceive it as a sort of complete replacement of what we were doing with traditional machine learning or traditional AI. And I just wanted to highlight that's not quite the right way to look at it. There's definitely a big step change in the capability that generative AI brings, and it's all based on training models on massive amounts of text and images without really the need to explicitly label the data. And so the resulting models are general purpose models. That's why we call them foundational models. They sort of understand the internal structure in language and images. Whereas in the traditional machine learning, we were really usually using labeled data to kind of emulate a particular human ability or a natural process. And the models were sort of built for a specific purpose. So the good thing with foundational models, such as the ones that are available in Amazon Bedrock, which is kind of our service that offers this generative technology, is to support many different use cases that could then be adapted, such as text classification, detecting sentiment, and it could also supplement many other sort of traditional use cases, such as personalization, for example. And then there are certain use cases where would still probably rely on traditional ML, such as regression models for predicting house prices, though now again, the generative AI technologies will augment these models by sort of allowing us to process the textual descriptions, if the case may be with predicting a house price, right? And maybe some additional information that could be extracted from images that go together. So I think that's how I see this distinction.
Thank you. And obviously, our listeners will be very interested in how we put this all into practice. So, Manish, can you speak a little bit about what you think the key factors are that enterprise decision makers should consider when implementing their generative AI technologies?
Yeah, I mean, just sort of building off what Dennis just said, right? So, yeah, I totally agree with him, right? So, for the first things, right, when I'm having this discussion with clients in terms of implementing generative AI, right, I sort of go back and ask them the question, right? I mean, do you have clarity and understanding of the business problem that you're trying to solve, and how the capabilities of foundation models, generative AI, sort of help solve that problem better, faster, right? And sort of goes back to sort of when do you use traditional AI, when do you use generative AI, how do you meld the two together, right? So that's sort of the number one thing, right? You always want to start out with having clarity on the problem that you're solving and that you're using the right tools for that. And then once you've decided that, right, there is a decision you have to make on the choice of model for the task that you are trying to address, right? One of the great things about the innovation boom that we are having around this topic area is that we have a lot of choices, right? Both open source and closed source options, large and small models, etc. Right? So you really do want to have to make that choice. I don't believe that there's going to be one model to rule them all, right? You are going to have to make a choice for the task at hand that you're trying to do, and what is the best model to use for that. And part of choosing the model also is making sure you have clarity and comfort with the data that was used to train that base model, right? There is, for good reasons, questions around, how some of these models got trained. The third area is around the deployment options and choices, right? Is it going to be public, for your use case, right? Is it public, hybrid, private, right? Are you going to train a model from scratch for your use case? You're going to fine tune an existing base model, right? Or you're going to prompt engineer a model and get that task done. Again, it's not a right or wrong answer. The choice on the deployment option, again, is based on the use case that you're trying to address. And enterprises are going to have multiple of these deployment options within the enterprise, right? Having this be purpose built for the use cases that they're trying to solve is very, very important. Then there are the trade-offs, right? The fourth area is the trade-offs that you need to consider, right? The trade-offs around accuracy, around cost, around latency, right? And again, there are different choices that you'll make. If you just look at cost, right? If you're going to use a public SaaS model, right, costs on millions of interactions, billions of tokens can add up, right? Do you want to then consider having a open source model fine-tuned, hosted locally, right? Maybe give you better latency, right? Reduce cost, etc. So again, you got to consider these trade-offs as you are deciding on the model to use. And I think the final thing is, to make sure that, like with any traditional machine learning AI models, right, and just good software engineering, right, that you have the operations of these once they are in production thought through, right? There are new things that foundation models, generative AI brings in, that is different from traditional AI in the space, right? So you want to make sure you're collecting user feedback, high quality signal there, right? Other task-based technical metrics, ways to use LLMs to evaluate LLMs, all of these things sort of come into play. So I would say these are sort of the five, key areas to consider as you are deciding on implementing generative AI within the enterprise.
And can you share some real world examples of Gen AI driven decision making that's resulted in significant improvements for businesses?
Yeah, I mean, there's tons of them. I'll just sort of try and walk through a few different ones, right? So we've been doing some great work with the French telco. Actually, it's on AWS, right? And there they were just, they get about 6 million calls a month, and the agents were struggling to ensure that they are documenting everything correctly in the CRM system. That they were using what was documented in the CRM system on prior interactions with the customer, so that they were using it for the next interaction, etc. And it was just not to the quality that they wanted. So we've helped them implement sort of a couple of things. One is sort of automatically summarize the conversation into a few key bullet points that go back into the CRM system, so that next time Manish calls in, Dennis needs to take the call, right? Dennis knows exactly what the previous conversation was about, right? You know, a classic problem, but they've now really got this good handle on it. The second thing we're also looking at, did Manish do all the right things based on the conversation? With the agent, with the customer, and took the right actions, right? All of this is having a significant impact on cost savings, but as well as the NPS for customers, right? It's takes away a whole bunch of after call work for the agents. They are happier. Customers are happier in terms of being greeted and known problems about what they've been calling in about. So that's one example of what we've been doing. And again, customer service is a very ripe area for applying this here. The second, I'll talk about is sort of for a very large global CPG firm, right? We have applied the same sort of techniques to verify the quotes from vendors against contractual discounts. And you would say, well, this is a boring back office process. Yes, but it was completely manual, right? You got an email, you looked at the email and the discounts for the items that were being sent over, right? Contractual discounts, were based on year-to-date spend and different tiers, etc. Right? So all of this needed to be manually verified, and we were able to sort of completely automate this process, right? Applying foundation models and generative AI to extract out all this information from the contracts, right? Extract out the information from the emails, right? And be able to do this match and then drive a variety of optimization in the downstream process and automation, right? Automatic emails or alerting the right person if there was a mismatch, etc. So again, drives a lot of productivity boost in an area that felt was needed to be manual. The third example I'll take is sort of a bit of a non-traditional, right? This is around production optimization. If you think about it, 25% of greenhouse gases are contributed by heavy industries, cement, steel, chemicals. And we said, IBM Research, IBM Consulting said, well, why can't we apply the techniques of, transformer architecture, et cetera, towards time series data? Each of these, cement mills, et cetera, right? We've been doing sort of production optimization for years, right, using regression models. We have 24 to 30 regression models for these mills. Applying foundation models to it, right, we were able to get it down to 2, one for process, one for quality. The results have been just phenomenal, right? What used to take 6 months, we can do in 8 to 10 weeks now. We have 7x improvement in accuracy. And what this translates to for the world, really, that sort of really heartens me, is 7 to 10% reduction in greenhouse gases from these industries. When you put this at scale, $2 per ton of cement, or $5 per ton of steel in EBITDA savings. So huge impact, of applying these kind of techniques to all kinds of different problems. There are lots more that I can talk about in terms of content generation, creating, going from designs that are created by AI all the way through applications that we are building with, using these techniques, or migrating applications and data on modernizing them, right? So just huge opportunity of applying these capabilities just across all aspects of business.
If I can maybe throw another example myself, Manish mentioned design. Well, if you look at like computer-aided design or CAD systems, generative design has become very important.
Yeah.
So it allows the algorithm to sort of explore what is possible. And in fact, one of the companies used SageMaker, which is another tool that AWS offers. It's a platform for building machine learning models, including generative models. And so they use SageMaker to build and train an AI-powered design tool that allows the designers to specify a set of constraints and create multiple candidate designs. And so a good example is work with an aircraft manufacturer to design part of a bulkhead of an airliner. And these have to be designed in such a way that they're incredibly strong and yet very, very light. And so the system came up with a new design for a bulkhead that is 45% lighter than previous designs, while at the same time being stronger. And so some back of the napkin calculations show that if spread across a global fleet of aircraft, this would lead to a fuel saving equivalent to taking over 90,000 cars off the road. So that's quite significant improvement, I'd say.
And Dennis, so what ethical considerations do you think organisations should be considering when utilising generative AI in their decision-making processes?
Yeah, very, very important topic because with the advent of these generative systems, there are clearly a number of things that we need to take care of collectively as an industry and then by individual companies. And so, of course, we've heard about issues around hallucinations, right? These models are generative by design. So we'd like them to generate novel content. And what is the distinction between novel content and a hallucination, right? In fact, it's any novel content is a kind of hallucination. It's just that we want it to be rooted in facts, grounded, and so it's important to have some controls around that. Of course, also toxicity. We want to avoid any kind of toxic language. We want to avoid bias and stereotyping, both in sort of prompts and the outputs that the system produces. We need to take care of personally identifiable information. So if the models were trained on such data, hypothetically, right, then, or if the answers produced by these models include such data, that they need to be kind of masked out. So what we're seeing right now is that model providers are building these controls in. And so that's why we're building our Titan models, first-party models on Amazon Bedrock with the necessary controls and guardrails to support that. And then each individual model provider is doing that. And then we're seeing also the emergence of various open source and proprietary tooling around these guardrails. And of course, copyright is becoming an interesting question. And we see the need for solutions in this space. And so, for example, our Amazon Code Whisperer service that generates code based on textual prompts actually has a feature called Reference Tracker, which detects if a particular piece of code that is generated is not identical even, but somewhat similar, sufficiently similar to some other code that was seen during training, then the system would automatically flag it and say, well, this code that was generated looks a lot like that, and that other code has this particular license, so the company then can decide whether to continue kind of incorporating that generated code in their code base. Yeah.
And do either of you have any sort of final thoughts on generative AI and what we can expect from it over the next year or so?
Well, I mean, what I would say is that, any enterprise, thinking about, every enterprise should be really thinking about how they can use the potential of foundation models, generative AI, in their business, right? To stay competitive, to create new and innovative services and products, right? And just to optimize how their businesses run. The technology is real, the opportunity is real, and the ones who apply it better and faster, right, are going to reap the benefits.
Any last thoughts from you, Dennis?
Yes, of course. So, this recent latest step change in capability definitely shows the staying power of the remarkable evolution of the AI capabilities over the past years. And, many customers are taking advantage of this, ranging from like companies like Coda AI, for example, who are building an AI-based like assistant for office work, all the way to Runway, which, if you watch the movie Everything, Everywhere, All at Once, they've actually used a machine learning kind of design tool to help with one particular scene. Well, of course, they covered many scenes, but there's one famous scene where like the rocks were moving through sand and dust towards a cliff. And so that tool saved days of worth of painstaking work and slash that basically converted to minutes. So we're really excited to be helping these customers realize the potential of generative AI, and we'll continue to do so together with IBM.
Thank you. Well, Dennis and Manish, thank you so much for joining us on Experts in AI. And we look forward to keeping an eye on what AWS and IBM get up to in this field in the near future. Thank you for joining me.
Thanks, Susie. My pleasure.
Yeah, thank you, Susie. Thanks, Manish.
To hear more from the guests featured on this podcast, head to their websites. Catch up on the latest and greatest insights in AI at aibusiness.com. Thank you for joining us, and please subscribe to the Experts in AI podcast to receive new episodes as soon as they drop. Goodbye for now.